Good morning, Cappuccino. Welcome to week 3, day 2 of distance learning and teaching. So here is our warm-up for today. First question, is this a valid probability distribution? So go check your notes about probability distributions. There's 2 rules that have to be satisfied for something to be a valid probability distribution. So go check your notes and do that problem. And then here, this is basically a calculator problem for the first one. So find the probability that x is less than 20 if you have a normal distribution with a mean of 16 and a variance of 2.5 squared. And then, same problem, I want to know what's the z-score for x equals 20. Change that to a z-score. Okay, so check the textbook pages that I sent you to look up how to compute a z-score and figure out what the z-score is for that. All right, and then the last problem is if I give you that z is normally distributed with a mean of 0 and a variance of 1, find the probability that z is less than 1.6. All right, on your mark, get set, go. Whoa, but wait, there's more. Okay, I only got 2 correct answers yesterday. What's up with that? Hello, middle school math. Let's go back and figure these out. Okay, I only got 2 correct answers. I got a bunch of incorrect answers, but only 2 that were correct. So let's go over this right now. And then I'm going to go over how to do problem 1E, I and II from a couple of days ago. All right, so the first one, x minus 100 equals 15. Everybody got this one right. Just add 100 to both sides, and you get 115. Okay, so that's if it's just x minus 100 equals 15. But what if it's this one? Okay, I already had people getting this one wrong. Think about it. What could be underneath my finger? If you can't see, pretend you can't see the x. Okay, you don't know what's under there. What could it be? It could be 15, because the absolute value of 15 is 15. Or it could be negative 15, because the absolute value of negative 15 is 15. So that means what's under my finger could equal 15, or it could equal negative 15. So x minus 100 can equal 15, or x minus 100 can equal negative 15. So there's actually 2 solutions to this problem. So add 100 to both sides, I get x equals 115. Add 100 to both sides here, and I get x is equal to 85. So it could be this, or it could be that. It could be both of those, all right? Could be this one, or it could be that one. Both of those solutions work. All right, problem number 3, inequality. So solve that same way as an equation. Just add 100 both sides. I get x is less than 115. Okay, does it matter when the inequality switches? No, it sure doesn't. Just add 100 to both sides, and I get x is greater than 115. Okay, so those are pretty straightforward. And then the last 2, this is where things get a little more complicated. This is a combination of these problems. So on this one, I have, just like if I were setting up the equal sign, there's going to, the absolute value with an equal sign, there's going to be 2 solutions. X minus 100 is less than 15, or x minus 100, and now here's where we get tricky. When we change the inequality, when we change the sign over here, we need to change the inequality. Is greater than negative 15. Okay, and we could run through how to prove why this happens, but that's not really the point of this whole problem. We're trying to do this problem to get at something else. Oh, somebody is calling. Why are they calling? I'm trying to film. Oh no. Good, they hung up. Sorry about that. Okay. So now we need to solve both of these inequalities, which we already did up here. So this is x is less than 115, and this one is x is greater than, let's see, if I add 100 to this, I get 85. Okay, so it has to be less than 115, but also greater than 85. So if you think about this on a number line, x is less than 115, so it's going to be this way, but it's greater than 85. So that's that way. So notice these 2 things overlap. So we call that an and. This is an and problem. So if you remember this back from whenever you learned inequalities, This is an and we can write an and like this. It's between 85 and 115. There's my solution. X is between 85 and 115. Okay, and then you could test it. We could test a number that's between 85 and 115. Say 100. 100's in between those. So if I plug in 100 here, 100 minus 100 is 0. The absolute value of 0 is 0. Is 0 less than 15? Yes. Okay, so the numbers in between here satisfy this absolute value inequality. All right, and this one, again, there's two possible solutions. X minus 100 could be greater than 15. And then the other one is X minus 100 is going to be less than negative 15. So when you change the sign, you got to change the inequality. And you'll see why that works out in a minute. So if we solve each of these, I get X is greater than 115. And this one, I get X is less than 85. Okay, by adding 100 to both sides. So let's see what happens if I put that on a number line. Here's 115. It says X has to be greater, that's going this way, and 85, that is going this way. So notice it's not the numbers in between. So let's test it. If we pick a number that's to the left of 85, here's an easy one. How about 0? And we put in that into our inequality. What's 0 minus 100? 0 minus 100 is negative 100. Absolute value of negative 100 is 100. Is 100 greater than 15? Yes. So check. This side works. And what about this side? Let's put, say, 200. 200 minus 100 is 100. Absolute value of 100 is 100. Is 100 greater than 15? Yes. Okay, so notice there's two sections. When there's two sections, this is an OR problem. So the answer is X is greater than 115 or X is less than 85. To write it more mathematically correct, we would write this one first because it has a smaller value. Or X is greater than 115. That is the perfect solution to number 6 from the warm-up. All right, so what does this have to do with problem 1E on the assignment from last week? Well, you can't put this directly into your calculator. You have to get this to say P of F is something, okay, before you can put it into your calculator. So we got to solve this. So we need to solve this problem. The absolute value of F minus 100 is less than 15. And we just did that. We just did that on our warm-up. Let's see, which one was that? That would be number 5. Number 5, we solved number 5, and what did we get? We got this one, okay? So that would be, if we solve this just like we did on the warm-up, we would get that F is greater than 85 and less than 115. Okay, so if you solve it, you get F is in between two values. So we want to get F is between two values, and that's really nice because that works great with our graphing calculator. So if I grab my graphing calculator, I'm going to go second bars, and I want my normal distribution because of the n there. Oops, can't see it now. Where is it? The n there. This is a normally distributed probability problem. Okay, so I want option 2 because it's cumulative. And my lower boundary is 85 because I want to be between 85 and my upper boundary is 115. And my mean is 100 and my standard deviation is 25. And if I do that, click, 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 I get 0.451. So what's the probability that a value will satisfy this, that the absolute value of F minus 100 is less than 15? What's the probability that will happen? 45.1%. Okay, so the answer is 0.451. All right, same idea for the next one. So for this one, I need to solve this inequality. So this one's a little bit different than, I'm just going to go ahead and do it, than the one on the warm-up because it's 10, not 15. So I have F minus 100 is greater than 10, or F minus 100 is less than 10. So if I solve this one, I get F is greater than 110, and this one I get F is less than oops, I forgot to change the sign, -10. Add 100 both sides, I get f is less than 90. Now, if I graph that, look what happens. Here's 90, here's 110. I want to be greater than 110, and I want to be less than 90. Well, I can't be both things at the same time. That means this is an OR problem. So f is going to be greater than 110, or f is going to be less than 90. So that means there's actually two things that satisfy this absolute value inequality. There's two solutions. They both satisfy it. And so that means we're going to take the answers from this one and we're going to add it to the answers for this one. Okay, so I'm going to find the probability that f is greater than 110, and I'm going to add that to the probability that f is less than 90. Okay, this is a situation where I'm a winner if I get these or if I get these. Both of these solutions make me a winner. These are my probabilities that satisfy this absolute value inequality. So now I need to do this on my calculator. So I went greater than 110. So that means my minimum value, my minimum value is going to be 110 because I want f to be greater than 110. So 110 is my minimum value. So what's my upper value? Something huge. Just go up, whatever. Put in a really big number. It's still the same mean and the same standard deviation. Get my answer there. I get 0.34458, whatever. Okay, so this is 0.345 if I round it to 3 sig figs. But I'm going to keep this in my calculator because I'm going to have to add it to this one once I find this one. All right, and then let's do the other one. Second, normal distribution. And here I want to be less than 90. So my lower limit is going to be some like majorly negative number. And my upper is 90 because I want to be below 90. Same mean, standard deviation, and boom. Oh, look at that. I get the same answer again. Whoa, that was interesting. Very interesting. Okay, so it's just the same thing again, so I'm just going to take that answer and times it by 2, because since they're both the same, that's instead of adding them, I can just multiply one of them by 2, and I get my answer, which is 0.689. Okay, so that was problem 1E, I, and II from, I don't even know what assignment that was. I'm sorry, I'd have to look it up. But that was the second printed out assignment that I gave you. That was not a math space assignment. There they are. All right, stay tuned for, oh yeah, where's today's warm up again? 10 points extra credit for the first person who gets it in, 5 points thereafter for the next, let's say 4 people. So a total of 5 winners. On your mark, get set, math.